Good afternoon. We are going to learn about inverses today, which is an area of math not super common, but something that you'll definitely come across. So Roman numeral 1, what is an inverse? Okay, so basically an inverse is the reversal of x and y. And it's got some similarities to the original, but typically you solve for y. So reversal of x and y, and then you solve for y. There are some similarities with the original, but not a ton. Okay, so here's an example. Let's say that f of x equals x squared. As you know, f of x is function notation. We can also write it as y equals x squared. Okay, so to do the reciprocal, or the inverse, to do the inverse, you're going to reverse the x and y. So x equals y squared, and then you solve for the x. So in this case, you would, solve for the y. You would take a square root, and you would get 2 y's, 1 comes out, positive and negative, square root x. Now remember, inverse is a reversal of x and y, not to be confused, despite me saying it, as reciprocal. A reciprocal is not the same as an inverse. A reciprocal is where you take a fraction, for example, 2/3, you flip it, you get 3/2. An inverse is where x is actually changed to y and y is changed to x. It doesn't involve flipping anything. So once you've done an inverse, the notation for inverse is a -1 in the exponent position. So f of x, that was read the inverse of f of x. And the inverse of f of x is plus and minus radical x. Okay, so that's finding how to find the inverse. Switch them, solve for y. Now we're going to run a test. Test to see if they are inverses. So the test to see if they're inverses, and there's an algebraic test and then there's a graphical test. Okay, so let's do the algebraic first. The algebraic test is if f of g of x equals x and g of f of x equals x, then f and g are inverses. That's your algebraic test. We'll practice that in just a second. Actually, let's do it with a new example, testing to see if they're inverses. Here's a new example. The example is if f of x equals x cubed plus 1 and g of x equals the cube root of x minus 1, we're going to test to see if they are inverses. So we first start by finding f of g of x. So g replaces all the x's in f, so we have cube root of x minus 1 cubed plus 1. Of course, when you cube a cube root, 1 comes out, x minus 1 plus 1. 1 minus 1 is 0, and that direction works. So now we're going to do g of f of x and see if that works. So f will go into g, so we will have the cube root of x cubed plus 1 minus 1, which of course go to 0. So the cube root of x cubed is also x. Because both of them resulted in an x, we can say therefore they are inverses. Okay, so that's the algebraic test to see if they're inverses. The graphical test to see if they are inverses are to see if f of x and the inverse of f of x have y equals x as their line of reflection. So basically you graph both of them and see if they have a line of reflection. Now I'm just going to do a sketchy graph of, let's see, I'll do the first example that we did. So I'm going to use, as an example, f of x equals x squared, and then the inverse of that function is plus n minus square root of x. All right, so if we were to sketch a graph of these, f of x equals x squared would be a parabola, so that one's pretty straightforward. Now this one, the second one, comes in two pieces. One of them will go upward, one of them will go downward. And as you can see, if I draw the line y equals x, it is a reflection between the original function and the inverse of the function. So that is another way to test that they are actually inverses of each other. Okay, part 2. One-to-one functions. One-to-one functions. All right, this is a specific family of functions, and it means that both the original and its inverse are functions. And there's a lot of math that we can do with that if they're both functions. One-to-one functions, another nice characteristic of them, is that the domain of f of x, the original, is equal to the range of the inverse. It goes the other way. The range of the original function is actually the domain of the inverse. All right, so let's do an example of this. Let's say that f of x equals x cubed, and this is a cubic function. The domain of x cubed is negative infinity to positive infinity. Let's see, and let's graph it. So f of x equals x cubed is a cubic function, like this. And let's go ahead and impose, just to make this interesting, let's impose a range on it of 0 to positive infinity. So I'm actually going to take this part off. The y values can only be 0 to positive infinity. So I'm going to take off that part, and that's the domain and the range. Okay, so let's find the inverse. So x equals y cubed. Take a cube root of both sides. You get y equals the cube root of x. Which ends up being kind of an S-shaped graph. So it sort of snakes over, looks like this. It's got that piece and it's got that piece. So if we know that these are one-to-one, because as you can see, they both are functions. They both pass the vertical line test, so they are a function. The original is a function, and the new one is also a function. By knowing that they are both functions, you can say that they are one-to-one, and that tells you the domain and the range of the new function without you having to even calculate it. So for the inverse, the domain is going to be the range of the old one. The range of the old one was 0 to positive infinity, so the domain of the inverse is 0 to positive infinity. The range of the inverse is the domain of the original, which is negative infinity to positive infinity. And what does that do? Okay. So we've got, you can tell that we're going to have 0 to infinity for the x's, and then the restrictions will be here. Anyway, so that is one way that you can figure out domain and range of one-to-one functions, is by knowing that they are one-to-one, and then you can simply swap domain and range with each other. Anyway, I hope that was helpful. One-to-one functions are pretty simple. Again, if you're not sure that these are really inverses, if you were to graph them, they would look something like that. And the line of reflection between the two graphs would be the line y equals x. So because y equals x is the line of reflection, you can confirm that they really are inverses of each other. All right, that's it. Pretty short day of notes. Have a nice afternoon.